Hello friends, let us today study about natural antioxidants. Before going to the natural antioxidants, let us understand what an antioxidant is. Actually, the antioxidants are substances which inhibit or delay the oxidation of a substrate when present at concentrations lower than the oxidizing substrate. They are used to counteract the deterioration of stored food products. They function by interfering with the free radical chain reactions and reduce the primary radicals to non-radical species. Food antioxidants are classified into two major types. They include primary antioxidants or secondary antioxidants. The primary antioxidants are generally phenols, hindered phenols or other miscellaneous compounds like anoxamer, toroloxy, ethoxyquin and so on. The secondary or synergistic antioxidants includes those which are oxygen scavengers, metal chelators and the other miscellaneous compounds like nitrites, amino acids, flavonoids, vitamin A, selenium and so on. The primary antioxidants are normally hydrogen donated antioxidant. As you can see in this figure, they can donate hydrogen atom or electrons to free radical species. The antioxidant free radical does not initiate another free radical due to the stabilization of radical by delocalization. The synthetic antioxidants which are most commonly used particularly in oils etc. to extend their shelf life are the one which are in the category of primary antioxidants, and they include butylated hydroxyanisole, butylated hydroxytoluene, propyl gallate and tertiary butyl hydroquinone. The secondary antioxidants function by hydrogen donation to lipid radicals or by quenching of the singlet oxygen, removal of molecular oxygen, regeneration of tocopherols, or they function by reducing the effectiveness of pro-oxidants. There are various metal ions and other agents which act as pro-oxidant in food materials. So, these secondary antioxidants are chelators etc. They reduce the effectiveness of those pro-oxidants, like for example, they convert ferric ion to ferrous iron forms. The metal chelators secondary antioxidants includes compounds like phosphoric acids, citric acid, ethylene diamine tetraacetic acid, amino acids and peptides and proteins such as transferrin or ovotransferrin etc. The metal chelators function by the formation of complex ions or coordination compounds with metal, prevention of metal redoxcycling, formation of insoluble metal complexes, or they also function by steric hindrance of interactions between the metals and lipid intermediates. The oxygen scavenger secondary antioxidants includes compounds like ascorbic acid, ascorbyl palmitate, erythroic acid, sulfides and so on. The antioxidants have synergistic properties the interactions of different antioxidants improves the effectiveness of each other. That is, the synergism occurs when mixtures of antioxidants produce a more pronounced activity than the sum of activities of the individual antioxidants when used separately. In fact, this provides synergistic behavior of the antioxidants provides the avenues for reducing the doses of individual antioxidants. So, it is a common practice to use mixture of antioxidants rather than one single antioxidants, and these mixtures may be a mixture of primary antioxidants plus secondary antioxidants, or this like for example, alpha tocopherol can be mixed with ascorbic acid, and even the primary antioxidant like suppose BHA and BST in an IL, we need to have 0.02% of antioxidant. For example, it is advisable to have 0.01 plus 0.01 of two antioxidants rather than having 0.02% concentration of one single antioxidant. So, the addition of use of antioxidants together provides a better effect on as far as the shelf life extension and other properties are concerned. Now, after having this explanation of antioxidants, let us now come to the natural antioxidants, because most of the synthetic antioxidants, they have one or the other problems, sometimes the health concerns and other concerns, their effect on food constituents, etc. So, nowadays there is a trend towards the use of natural antioxidant in place of synthetic antioxidants, and majority of these natural antioxidants are generally plant extracts, like for example, tocopherols. They are present in IL seeds, they are also known as vitamin E. So, tocopherol and their derivatives are examples of natural antioxidants. The other compounds like ascorbic acid or vitamin C present in fruits and vegetables, beta carotene, extracts of herbs and spices such as rosemary, sage, thyme, oregano, etc. are the examples of natural antioxidants. The polyphenols present in the plant extracts are the potential source of antioxidants. Tocopherol, you can see the structure of tocopherol in this figure. In the phenolic rings, there are three groups R1, R2 and R3. So, depending upon the nature of these R1, R2 and R3, which are normally methyl group and pharmyl group, the tocopherols are of four types. For example, when all the three like on the 5, 7 and 8, all these three are methyl group, it becomes that is a 5, 7, 8 trimethyl tocol, it is alpha tocopherol. When at position 5 and 8 there are methyl group, and at position 7 there is a pharmyl group, the resultant tocopherol becomes beta tocopherol, and similarly gamma and delta tocopherols are there. And all these tocopherols have good antioxidant potentials. They function by the transfer of phenolic hydrogen or by scavenging of singlet oxygen. Flavonoids are the other group of secondary antioxidant, which are they are generally secondary products of plant metabolism. They are metal chelators, they are superoxide anion scavengers and hydrogen donors. Anthocyanins, catechins, flavonones, isoflavonones, flavonols, etc. belong to this group of antioxidants. fruits and vegetables are excellent sources of natural antioxidants. Fresh fruits like apple, pears, grapes, citrus fruits, etc. Vegetables like potato, tomato, spinach, carrot, all these they contain lot of antioxidants. The common antioxidant compound in these fruits and vegetables are phenolic compounds. Wine is a good source of anthocyanins, which are other good antioxidant potentials. In the tea, green tea and coffee beans, the polyphenolic compounds like epicatechins, epigallocatechin, chlorogenic acids, etc., are the major antioxidants compounds. In herbs and spices like rosemary, sage, ginger, turmeric, green pepper, lavender, etc., they contain lot of polyphenolic compounds and other compounds which have antioxidant properties. In fact, these spices like ginger, they contain gingerol. Other spices are used for their antioxidant properties from the time immemorial in different preparations. Some of the compounds with significant antioxidant potentials in these materials include carnosic acid, carnosol, rosmarinic acids, and so on. The antioxidants found in turmeric include curcumin, dimethoxycurcumin, bis-dimethoxycurcumin, and so on. The soybeans also contain good amount of natural antioxidants. Phenolic acids like chlorogenic acid, caffeic acid, and ferulic acids are found in soybeans. They are metal chelation and single oxygen quenching. They function by chelating of metal ions as well as singlet oxygen quenching. Isoflavones in soybeans work by metal chelation as well as hydrogen donation. So, these antioxidant, natural antioxidants, they are very good for use in the food materials. They are being now encouraged. However, there are certain advantages and disadvantages both for use of these natural antioxidants. The advantages include that they are readily accepted by the consumers. They are considered to be safe, and in fact, no safety tests are required by regulatory agencies if the component being used as a natural antioxidant is a food material or extract of the material which is being used generally as a food, or it is listed in the category of grass that is generally recognized as safe. So, there is no problem, it can be used without any disadvantage. However, there are certain cautions to be imposed with the use of natural antioxidants, or which in other words we can say disadvantage of using it, that they are usually more expensive if purified, but if they are not purified, they becomes not efficient. For example, suppose vitamin C as a source of antioxidant is to be used. So, we can take citrus juice. If it is being used in the form of citrus juice, so its antioxidants potential may be little less effective, but if the ascorbic acid is extracted from this juice using standard procedures and protocols, then its antioxidant potential can be increased, but the extraction methodologies other thing will add to the cost of the. So, it will become more expensive if purified and less efficient if not purified. And when it is used in not purified forms, of course, its activity may vary differently depending upon the differences in the concentration of the materials which are used. Also, the safety of this, particularly if this a herb or a spice or a plant material from which this compounds with antioxidant potential are extracted, they may have a good antioxidant properties, and if the compound is not edible, if the material, food material from which this antioxidant is extracted, if they are not edible, then the safety of this product becomes a concern. Other disadvantage may include that these extracts, unpurified form of extract, that is at the concentration which might be required to give the desired antioxidant effect, at those concentrations it may impart undesirable color, aftertaste or off flavor in the product. So that becomes another major limitation of the use of unpurified form of natural antioxidant or the extract, plant extract directly in the food material as a source of antioxidant. Then another important factor for consideration in the antioxidant is its polarity. In fact, the polar antioxidants are more active in bulk oil system than those of the non-polar antioxidants. As you can see here in the picture, if the hydrophobic antioxidants are located on the interface of the oil and water, as you can see here in the picture in the middle, then they are more effective, they can protect the lipid better than the hydrophilic antioxidants. Okay. Here in the first one you can say that is the air inside and oil, and the hydrophilic antioxidant is present in the interface of the air and oil. In the third picture, hydrophilic antioxidant is present in the interface of the water and oil. So, the one in the middle one you can say it is better, more it has more effective, that is the where the hydrophobic antioxidant is present in the at the interface of the oil and water. The partitioning properties or antioxidant potential of these compounds depends on the various factors, and those include the chemical structure of the compound and its polarity, the types of the lipid substrate, the presence of surfactants, and the composition of the phases, that is the water, air, oil and other phases in which that is what is their composition, type of the glycerides etc. present in that may all influence the partitioning properties of the antioxidants. So, can say that an ideal antioxidant should have no harmful physiological effect, it should have no objectionable flavor, color or odor, it should be fat soluble, so that it can easily dissolve or easily it can mix with those oils etc. to provide a better antioxidant properties. And more importantly, these antioxidants should be effective in low concentrations. They should not be absorbed by the body. They should be readily available, and finally and most importantly that they should be economical to use. That is, so it is always better that is, as far as the natural antioxidants are concerned, it is better if they are used in the form of their juice or their extracts. However, that is, these extracts, it should be properly optimized and standardized, so that at the level of concentration required to give the desired antioxidant effect, it should not impart any undesirable undesirable property to the material, or it should not particularly affect the sensory attributes and other functional characteristics of the component. So, these natural antioxidants have a lot of potential. They can be used for shelf life extensions of food materials. As I told you in the beginning of this lecture itself, in our laboratories we have worked on the use of natural antioxidants like those extracted from that rosemary. So, the rosemary extracts as well as the curcumin extracted from turmeric. So, the rosemary extracts were used in different concentrations for studying their effect on the shelf life extension of sunflower oil, and also the experiments were conducted to see how the frying stability or oxidative stability of the sunflower oil or such similar oil which has more PUFA content is improved by addition of these rosemary extracts or such other natural antioxidants. And our study indicated that addition of these extracts improved the oxidative stability of sunflower oil. It resulted into the shelf life extension. It improved frying properties of the oil, and very importantly, the products which were fried in such oil, for example, potato chips fried in the oils, sesame oil or sunflower oil containing rosemary extracts, they exhibited better stability during the storage. Similarly, the natural colors and antioxidant extracted from turmeric like curcumin and this curcumins, they were added into the oil. Experiments were conducted, and it was observed that not only these curcumins extended the shelf life of the oil, but it also added to the color of the oil, and the products fried in such oils were found to be attractive golden brown in color, and which was liked by the sensory panelists, etc. So, these natural antioxidants, they improve the shelf life of oil, they improve their oxidative stability, they improve the oxidative stability of the products fried in these materials. So, but before these natural antioxidants are used by the industry, or before they are used continuously, there are certain issues which needs to be resolved. For example, it needs to be studied and seen that whether the regular use or long term use of natural antioxidant, if it is having any pathological effect on the consumers and other persons who are using these materials added with the natural antioxidants, their carcinogenic potential, the interactions with the enzymes, etc., particularly in the food where these materials are added, and these when they are consumed, these natural antioxidant along with the food, then what are the different interactions these natural antioxidants might have with the food enzyme or with the body enzymes, etc., what type of effects these are likely to have on reproduction process and all those things. Even the exact nature or the mechanism in which these natural antioxidants get metabolized in the food as well as in the human system, and overall that is, as we seen, that it's a effect that long term use will depend upon more and more information on these issues, and but ultimately we can say that these natural antioxidants have a very good, great potential for being used in the food products, particularly those products which are likely to be spoiled by oxidation processes or auto oxidation processes. There these food grade natural antioxidants can be effectively used to improve their oxidative stability, to improve their shelf life without having any adverse effects on the sensory and other characteristics. Thank you very much.